Working with squares and cubic roots is very straightforward. The only prerequisite knowledge you need is your multiplication facts or a multiplication chart. As long as you have those facts available, then you're in good shape. The concept here is, well, let's start on the left-hand side with square roots. And what we're trying to determine is, in this number right here, what number times itself equals 25. And this is where your multiplication facts come in handy. If you know that 5 times 5, right, 5 times itself, 5 times 5 becomes 25, then what you could do is you could rewrite the 25 as 5 to the second power. And then anytime you see this symbol with this symbol tucked inside, they effectively cancel each other out. And you're left with this answer only. Now, your math teachers might say that there's a positive version of this because 5 times 5 is 25. And there's a negative version of this as well because negative 5 times negative 5 is 25. But also, they'll tell you that if they really want the negative version, they'll put a negative sign in front. And if they want you to have the plus and minus sign like I have here, they will put a plus or minus in front of. If you don't see those things, they're usually referring to what's called the principal square root. And the principal square root in this example is the positive square root. So you should be confident in just saying 5. Now, it works also with decimals as long as the number here, called your index, and the number of digits that are are in your decimal are multiples of one another. So there's 2 digits here, which means I can have a single digit times a single digit. Remember, a single digit times single digit means 2 digits. So 0.7 and 0.7, weirdly enough, are going to be 0.49, 2 digits. So this one is 0.7. All right, very straightforward. If you would have had like another number on here though, like a 1, grab a calculator or estimate it as best you can. If you have fractions, you're allowed to deal with the fractions individually. This one has a negative in front, but you can deal with it like this. You can just do the top number and you can do the bottom number as 2 separate numbers. So the square root of 9 is 3 times 3, so 3, and 4 times 4 is 16, so there's your answer. And finally, if you have a square root and you have a negative, that's impossible. It's impossible with the numbers we're working with. So we're going to go ahead and say no real solution. There are technically imaginary solutions to this, but that's beyond what we're doing here. So let's go ahead and say no real solution. On the cubic root side, the only difference is we're looking for 3 numbers that are all the same that are multiplying together to give you -1. The negatives all of a sudden can work because you could have this function. So -1 for the first one. Notice 3 digits in the index of 3, so that's okay. So 0.2, 0.2, and 0.2 multiplied together give you 0.008. So this one is 0.2. And just like the previous one, you could go ahead and do this with the top and the bottom separately. Sometimes that helps you to keep organized. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So I have -2/3. And that's the simple way to work with square and cubic roots.